Okay, so if you look at the textbook, they won't even say this 0. So when they're going to talk about there's 1, 2, 3, 4 forces, they don't even acknowledge this part because it's been multiplied by 0. I'm putting it in here just so that you know, but I'm not going to make a big thing of that anymore. Now, the next force they're going to say is, well, I've written this symbol here because I don't know if it's plus or minus yet. And I'm going to write it's 50. Now, it's 50, so it's 5 tons at Earth gravity, which is 50 kilonewtons. It is 10 meters away. Now, we're pushing down relative to point A. Is that going to go clockwise or anti-clockwise? So we're going clockwise. So we're going to turn that into a positive. Now, your book doesn't say that because it just says simply 50, right? If you look over there, it just says 50. Now, it doesn't use this symbol. I like to use brackets. And then brackets make it really clear. It makes it really easy to read. And it takes me a few years to develop this system. If writing brackets just means that the next person who comes and looks at your work can see straight away what's going on. 50 times 10, right? And then the next force is going to be, now the next force is a bit tricky. The next force is going to be 30, but it's not 30, it's 30 sine 45. The reason for that is because if we're taking, or we can go, if we're going to go 45 in this degree here, this angle, right? We could use 40 cos 45, would work as well. We'll work 40 cos 45, that works relative to that. Now, at some other point I will explain to you why that is the case, but for the moment we're just going to run with it, right? If you don't understand that level of trigonometry, you need to let me know and I will talk to you about it. Now, how far away is it? It's 2 times 10 away. Then finally, we've got our last force, which is RB. Oh, is this going clockwise or anti-clockwise?
Clockwise.
Clockwise, sorry. We've got RB, and RB is 3 times 10. Is it clockwise or anti-clockwise? Relative to RA, relative to point A, if we're pushing up, it's going to turn this beam anti-clockwise. So we're going to leave that as a minus sign. Now, I've already said I'm not going to say this again. We're going to bring that over to the other side, swap the sign. So we're going to get 30 RB equals, and so it's lost the minus sign, equals 500. And then, okay, so 30 sine 45, we've actually figured out as 21 point something. Right? I think it's 21.21, is that how it goes?
21.213.
21.213 and times 20. Okay? So that's going to be, can someone multiply those numbers? It's going to be
424.26.
424.26. Okay, if we add that together, we're going to get equals 924.26. RB equals that number divided by 30, right? If we've got 30 red balloons, how much is it going to cost? Okay, so our answer is going to be 40 something?
30.
Oh, sorry, 30 something, yeah, that makes sense.
30.81.
30.81, yep. Okay, now the answer is positive, right? So we're going to write kilonewtons up, and then I'm going to write in blue to say that you don't need to write this. This is not something you need to write in the exam, but I do because it's helpful for me. I'm going to write positive, therefore our assumption was okay. Okay, now, once we've found RA, we've found the reaction at B, what we can now do is we can find the vertical component of RAV. We could do that by taking moments about point B, and a lot of people do, but I'm not. I'm going to take moments about, I'm just going to take the sum of the forces vertically to find that missing force. Now, I've got a question.
Is it supposed to be a positive plus 500 plus 2?
Thank you for helping me catch that, yes. Thank you very much. Anyone else? No? Great. Okay, cheers. Okay, so what we've got now is we're going to do our sum of our forces vertically. Now, I must say I have trouble doing this, right? The way they'll do this in the book, so you've got the book on the whiteboard on the other side of the screen, but I'm going to move it to the top here. Right, they've said sum of the forces vertically equals 0. They've got 0 equals 30.81 minus 50 minus 30 sine 45 plus RB. And what they've then written is RAV, therefore must equal, RAV. RAV equals 40.4. And filling these up. Now, personally, what I like to do is, we've done this before, we're going to do it one more time now. We're going to say, okay, we've got RAV, which we don't know. We've got 50 down. We've got 21.21 going down. So 21.213. We've got 50, how much we've got going back up? Sorry, 38 going back up. 30.8. And we've got a missing value, which we're going to call RAV. Now to me, that way of expressing my equation just makes so much more sense to me in my head than writing this out, that's why I do it. So I'm going to continue to do that rather than the way the textbooks don't. The textbooks don't because they want to be factually as correct as possible, but for me this just makes so much more sense. Yeah, what's up?
If there's a question and the bridge is actually broken,
It's not going to be,
not going to be.
there will, in the HSC we'll only ever work with bridges that are in equilibrium, every time. Okay, what is the value of RAV? Equals 40.4 kilonewtons up. Okay, now what we do have to figure out as well is we also have to figure out RAH. How are we going to find RAH? How do we find out RAH? We have three formulas here, right? We have sum of the moments. I don't know if this is in the screen or not, but we have sum of the moments equals 0, sum of the forces vertically equals 0, and we have sum of the forces horizontally equals 0. So in this case, what we can do, we write that formula up. Sigma forces horizontally equals, so the sum of the forces horizontally setting to the right as positive. What have we got? Well, we know that we've got this force here, which is 21.213 in that direction, and we've got RAH. And they're going to have to equal each other, right? In order for that to be equal to 0, that's how I would write that. Now, if you look at the textbook on page, the Copeland book on page 15, you can see how they write it, but that's how I write it. That's how I solve it. Now, we've solved RB. All right, let's write that in. RB, we've figured out the red balloons were $30 each. 38. We've found RAV. We've said RAV equals, we figured that out here, was 40.4. Right? And now finally, what we found RAH is equal to 21.213. But now what we need to do, now I'm going to rub this out, but it will be available, so you can copy it out later. It's also directly in the textbook on page 14, 15. What we're going to do is we're going to find out what is the value of RA as a, like this. We're going to say RA as the sum of those two vectors. So RA is going to be the sum of these two vectors. It's going to be the sum of 21.212 and the sum of the sum of 40.4. How do I find the value of RA? Sorry?
A square root of A squared plus B squared.
Excellent. RA equals the square root of 21.213 plus 40.4 squared. So everyone is familiar with Pythagoras' theorem, literally year 7 maths, right? Now, I agree, it's time consuming and there's room for error here. Now, what I will say, the important thing to always remember is that this is the hypotenuse. Yeah? So the number that we're looking for must be bigger than what? It must be bigger than 40. Has to be. Yeah? What's up?
How did you find RAH again?
RAH? Well, we said that the only force that we have is this one here. We can effectively rub that out, and what we can do is we can replace it with these two forces. Right? We can effectively replace it with 21.213 and 21.213. And we said if we have the sum of the if we have 21.3 pushing this way, we're going to have someone pushing 21.3 that way. Yeah?
Is that all it is?
Yeah, that's all it is. Who can do it? Is it going to be RB or RA? It has to be RA because Penny can take that, right? So, has anyone typed this in the calculator for me?
Yeah.
What is it?
45.63.
Okay, 45.63 kilonewtons. Now, we need to know the angle. Now, I always measure the angle. Now, we could measure the angle from here, or we could measure the angle from here, right? I would always, the convention is to always measure from the horizontal. That's just the convention. You don't have to, and as long as you clearly show what you're doing, as long as you clearly show theta equals, as long as you say theta rather than phi, people will be fine with it, right? They're there to give you marks, not take marks away. But what people will typically do is they'll typically write the angle in like that. So that way there can be no confusion. Yeah, we'll typically write, and that's what the textbook has done. But let's figure out the value. How do we find the value? So we know that tan theta equals opposite over adjacent. Let me write that in for you. Tan theta equals opposite over adjacent. So opposite is 40.4 over 21.213. So what that means is theta equals tan to the minus, inverse of tan, or arctan is if you use it on the Excel. Opposite over. And the answer we get is Were you all happy with that? Yeah? Great. Okay.
Yeah.
You can use anything, right, sir?
What do you mean?
Sine, cos, or tangent. Because we have
In this
our
case,
angle.
yes, in this case you could. If that was what you wanted, you could. Cameron?